Okay. So in the last lecture, we were talking about the revision of operating system. So just will revise once again all the points and then we'll proceed further to our topic. So in the operating system, we discussed about first chapter, that is definition of operating system, then types of operating system, simple, multi-program, time sharing, personal computer system, parallel system, real-time system, and last that is system calls. And again, in the last lecture, we discussed about system calls. So system call, it is the interface between user and operating system. And operating system, it is the interface between user and computer hardware. So this is the basic difference between definition of operating system and system call. So what is OS? OS is the interface between user and computer hardware. And what is system call? So system call, it is the call of system. It is predefined by the system and it is used by the user to interact with the operating system. जर आपल्याला युजरला ऑपरेटिंग सिस्टम बरोबर इंटरॅक्शन करायचं असेल, so we are taking the help of system calls. Okay, so different types of system calls are there. So again, I said in the last lecture, throughout the Unix operating system, we are learning lot many system calls. So we'll see at the time of a syllabus. Under second chapter, again, we covered the concept of process. So process, it is the program under execution. So when the program will be in execution, so when we are saying, you are familiar with C program. So you are writing C program, you are saving it on the hard disk, then you are compiling it, and after compilation, you are saying run. So when you are running, so that program will be under execution, and that program will be get converted into number of processes. So that is process is the program under execution. So before maybe 10 minutes before, my program was to conduct the operating system lecture. Before 10 minutes, my program was to conduct the operating system lecture, and now that lecture is get started. It means my program is now under execution. Okay, right? So like that, program in execution or program under execution, it is called as a process. It is the basic definition of process. Then we discussed about scheduling, process scheduling, operations on processes. So two types of two major operations are done on the process. One is process creation, and second one is process termination. So creation is done with the help of fork system call, and termination is done normally with the help of exit system call. So sometimes it is also done with the help of abort system call. So two types of process terminations are there. One is normal termination, another is forceful termination. So normal termination is done with the help of exit system call, and the forceful termination is done with the help of abort system call. Then we discussed about cooperating processes. So normally in our real life also, so n number of processes are there which are treated as a cooperating, that is dependent processes. So two types of processes are there, dependent and independent, and mostly majority of the processes are dependent. They are dependent on each other, like us. So we are the human being, so we are unable to live without the society. That's why, so we all are dependent on each other. So that's why in our real life also, so whatever number of processes are there, so maximum processes are cooperating processes, and very few are, or you may say that exceptions are there which are treated as a independent processes. Then we discussed about interprocess communication. Under interprocess communication, we discussed different methods, that is direct communication, indirect communication, synchronization, then blocking. These are the different methods which are, these are also treated as a message passing mechanisms. So different primitives we discussed with respect to these methods as a part of IPC. So this is about the second chapter. Then in the third chapter, we discussed about basic concept, what is process scheduling, or why it is required. So when the system consists of more than one processes, so there is need of process scheduling. Further, we discussed about scheduling criteria. So that is CPU utilization, throughput, then time, turnaround time, response time, and waiting time. So like that, we discussed the scheduling criteria. So based upon these criteria, we are scheduling the processes. Further, we discussed different scheduling algorithms, that is FCFS, SJF. We discussed SJF as a preemptive as well as non-preemptive. Then we discussed that RR scheduling. Then we discussed about priority scheduling. So basically, the question frequently asked question at the time of interviews regarding this process scheduling. So they may ask you what is process scheduling, why it is required, what is by scheduling, what are the different types of schedulers, what are the different types of scheduling algorithms. So what are the scheduling criteria with respect to each algorithm? For example, if you consider FCFS, first come, first served. So can anybody tell me what is the scheduling criteria? First come, first served. Which factor is treated as the most important factor in this algorithm? Come on.
Arriving time of process.
Good. Arrival time of a process. So we are basically considering the scheduling parameter as a arrival time. So based upon the arrival time, we are scheduling the processes. So like that, each scheduling algorithm is having its own scheduling criteria, its own factors, which will be considered at the time of scheduling. So second, that is SJF, we are considering the burst time or execution time of the process. So whatever process, whichever process requires less amount of time, so that is scheduled first, shortest job first. So again, in that shortest job first, two types of scheduling are there, preemptive and non-preemptive. So can anybody tell me the difference between non-preemptive and preemptive? Again, this is the frequently asked question at the time of technical interviews. What do by preemptive scheduling? What do by non-preemptive scheduling? How can you define it or how can you justify it? Can anybody? Come on. Who will tell me the difference between non-preemptive scheduling and preemptive scheduling? Actually, FCFS, it is non-preemptive scheduling. SJF, it is non-preemptive as well as preemptive. So what is the difference between preemptive and non-preemptive? In detail, we covered as a part of OS first semester. Any one student from the whole class?
In preemptive scheduling, we can divide the process into many parts and we can run it in different on different time. But in non-preemptive scheduling, we should execute the whole process in a single one time.
Good, very nice. So in case of non-preemptive scheduling, once the processor is allocated to that process, so it will be get deallocated at the end of the process. म्हणजे एकदा प्रोसेसर त्या प्रोसेसला दिला, जोपर्यंत ती प्रोसेस कंप्लीट होत नाही, जोपर्यंत त्या प्रोसेसचा बस टाइम कंप्लीट होत नाही, तोपर्यंत त्या प्रोसेसला आपण तोपर्यंत तो सीपीयू त्याच्याकडून डिअलोकेट करत नाही. सो आय एम टॉकिंग अबाउट allocation of CPU, that is processor, and deallocation of the processor. So in case of non-preemptive scheduling, once the processor is allocated to that particular process, it will be get deallocated at the end of the process. That is, the processor will be allocated to that process throughout the burst time. So whatever burst time is required by that process to execute on the CPU, so the total amount of time the CPU will be given to that process only. And once that process will be over, then only the CPU is switched from that process to any other higher priority process. But in case of preemptive scheduling, so whenever any higher priority process comes, so we are immediately switching the processor from current process to that higher priority process, right? So in case of SJF, I said that SJF is preemptive as well as non-preemptive. RR, it is totally preemptive. Priority scheduling, it is totally preemptive. So like that, we discuss the concepts again with the help of algorithms. So these are the different scheduling algorithms. Then we discussed about multiple processor scheduling. So multiple processor scheduling, it is totally required for parallel systems, that is multiprocessor system. If the system consists of more than one processors, so each processor is having its own queue. Each processor is having its own queue, its own scheduling algorithm. So for example, if there are 5 processors, C1, C2, C2, C3, C4, C5, so C1 may use FCFS, C2 may use SJF, C3 may use priority scheduling, C4 may use RR scheduling. Like that, each and every processor is having its own requirement. It will decide its own requirement which algorithm should be used for scheduling purpose. And accordingly, the processes will be distributed within these processors. So under multiprocessor scheduling, we discuss the concept of overloading and underloading, right? So overloading, so as we taken the example, 5 processors are there. So if there are 10 tasks, assuming that each task requires same time. So if there are 10 tasks, So each processor should execute 2 tasks. So it is called as a load balancing. That is, the load is equally distributed within the processors. So if the load is not distributed properly, so it will be underloading or overloading. That is, out of 10, if 4 they got only one task, and if remaining will get 6 tasks, so I may say that remaining one is overloaded. The remaining one processor is overloaded processor, and remaining that first 4 processors, they may be underloaded. So underloaded, that is, they are having very less task to execute, but one is having more task than its capacity. So the concept of overloading we discussed. So how to balance that load, etc., etc. So different mechanisms are used. So I have shared the notes with you people. Just go through it. So this concept we discussed as a part of process scheduling. After process scheduling, we discussed about interprocess synchronization. Under interprocess synchronization, we discussed about the basic requirement behind the synchronization, why synchronization is required. So it is communication with respect to time. So if you consider the same time, at the same time, sender as well as receiver, they are communicating with each other. It is called as a synchronization. Otherwise, it will be called as a communication, right? Sender आणि receiver एकाच वेळेस जर एकमेकांशी कम्युनिकेशन करत असतील तर त्याला आपण सिंक्रोनायझेशन म्हणतो. आणि जर ते वेगवेगळ्या टाइमला कम्युनिकेट करत असतील एकमेकांशी, सो दॅट इज ट्रीटेड ॲज अ simply communication, interprocess communication. And I discussed the best 2 examples. One, chatting. So chatting through any channel. So if I am doing chatting, so I am a sender, maybe you are receiver. So if I say hi, you will say hi. I will say how are you, then you will say how are you. So this is the kind of synchronization. So based upon each other's response, so we are proceeding further, right? So this is the best example under synchronization. And if you consider the example of sending emails, so I am a sender, you are the receiver. I will send mail right now, and you may receive, or you may check that mail maybe tomorrow. That is, we are communicating. I'm sending some message to you, but I am sending today and you are receiving or you are reading it tomorrow. So at a different times we are communicating, and it is the best example of interprocess communication. Okay, so these are the 2 best examples to understand the clear difference between interprocess communication and synchronization. So under this chapter we discussed about critical section problem. So how many sections are there basically with respect to process? Can anybody tell me? Come on, hope you are listening to me. Yes, students, in the 4th chapter we discussed about critical section problem. So before discussion of the problem, we discussed about sections. So each process is consist of basically different sections. So what are these sections, or how many sections are there? Yes, anybody? Yes, how many sections are there with respect to one process? Each process is having its own typical view, and that view consists of number of sections. Come on, who will tell me? प्रत्येक प्रोसेसचे त्याचे ओन सेक्शन्स आहेत. किती सेक्शन्स आहेत आणि कुठले कुठले सेक्शन्स आहेत?
Code section, data section, stack, heap.
Okay, so you are talking about the section. Actually these are not as sections. So this is the part of data. जर मी प्रोसेस डिफाइन केली, so again different definitions are there. Just now I said that process, that is program under execution. Further I may say that process consists of 3 types of data, and you rightly mentioned these 3 types, that is data section, code section and stack section. Okay, further again with respect to the utilization of local variables and global variables, with respect to the utilization of local variables and global variables, so few more sections are there. Can anybody? आपण जेव्हा क्रिटिकल सेक्शनचा कन्सेप्ट डिस्कस केला त्यावेळेस प्रत्येक प्रोसेसचे काही सेक्शन्स असतात. ते किती असतात आणि कुठले कुठले असतात? whatever data stack and that code section you discussed, so it is with respect to contents of the process. So like critical section, how many sections are there? Again, I have given the clue. So when these sections are utilized with respect to the utilization of local variables and global variables, or public variables and private variables. जर कोणाला आठवत असेल, आपण जेव्हा आयपीसी मध्ये सॉरी इंटरप्रोसेस सिंक्रोनायझेशन मध्ये वेगवेगळे अल्गोरिदम डिस्कस केले, तर ते सगळे अल्गोरिदम आपण एका फॉर्मॅट मध्ये लिहित होतो. Yes, anybody? Okay, so let it be. I will just take the help of OS so that you can recall. So in 4th chapter, we discussed about critical section. So these were the notes. So while we were talking about critical section, so actually we discussed first of all critical section problem, and then we went to the critical section. Okay, so this is the critical section problem. So segment of code called as a consider a system consisting of n processes. Each process has a segment of code called as a critical section in which the process may be changing common variables. काही variables common असणार आहेत. Common म्हणजे public किंवा global, जे एकापेक्षा जास्त processes share करतात. And some variables are totally uncommon, that is local, private. Okay, so here we discussed about the structure. So this is the general structure of typical process. So entry section, critical section, exit section, and reminder section, right? Once again I will repeat, each process is having its own typical structure, and that structure consists of total 4 sections: entry section, critical section, exit section, and reminder section. So entry and exit, these are with respect to the critical section. What is the critical section? Critical section मध्ये कुठले व्हेरिएबल युटिलाइज केले जातात प्रोसेस कडून? तर कॉमन व्हेरिएबल्स. कॉमन व्हेरिएबल्स म्हणजे ग्लोबल व्हेरिएबल विच आर शेअर्ड वन. म्हणजे एखादा व्हेरिएबल आहे, एखादा रिसोर्स आहे, तो 2 प्रोसेसेस मध्ये मे बी त्यांनी शेअर केलेला आहे. सो दॅट इज द critical section. And to enter in that critical section, they have to go through the entry sections. What is my entry section? So in the intersection, they have to check the status of that common variable. So what is the status? Whether that variable or that resource is busy or free, right? And once they complete the task inside the critical section, so they have to come to the exit section. And in the exit section, they are just deallocating the resources, whichever they acquired inside the critical section. And while I was talking about this structure, so frequently I taken the example of washroom. So washroom is the best example to understand the concept of critical section. So inside the washroom, only one person is able to enter. So before entering, they have to enter in the entry section. They have to check the status of that resource, whether it is busy or free. If it is free, they are able to enter inside the critical section. And once they come from the critical section, they have to go to the exit section, showing that or just releasing that resource. So once that resource will be released, so another process may be going to enter in the entry section. Again, that second process is able to get that critical section as a totally free section. It is able to enter inside the critical section. Again, the task will be performed, and the process is again coming to the exit section. Once the second process comes in the exit section and goes to the reminder section, again third process may be in the entry section, like that onwards. So in the sense, only one process will be executing inside the critical section because it is shared one, because it is global one, because it is a common one. Or you may take the example of reference book. So assume that 5 students are there and only one reference copy is there. So how they are able to read that book? So at a time, I can't say all of 5 to read that book. So at a time, only one student is able to read that book. So when the first student is reading the book, so others, they have to just wait. Once the first student completes the reading, maybe not whole book, maybe part of, or maybe few pages of that book. So again, second process will be in the entry section, like that onwards. So n number of examples are there in our real life, day-to-day life, where we are applying the concept of synchronization. So these are the four sections, that is entry section, critical section, exit section, and reminder section. So what about reminder section? So it is opposite of critical section. In critical section, process utilizes the common variables, and in reminder section it utilizes the local variables. त्याचे स्वतःचे जे काही व्हेरिएबल्स असतील किंवा त्याचे स्वतःचे ओन जे काही प्रायव्हेट रिसोर्सेस असतील ते कुठे यूज करतो तो रिमाइंडर सेक्शन मध्ये, बिकॉज दे आर टोटली ऑफ इफ्स. जर एखादं रिसोर्स, जसं की मी आता तुम्हाला एक्झाम्पल सांगितलं की रेफरन्स बुक एकच कॉपी आहे आणि 5 स्टुडंट आहेत, त्याच्याऐवजी जर तुम्ही सपोज असं अजूम करा की त्या 5 स्टुडंटकडे त्यांचा पेन आणि त्यांची नोटबुक आहे. So when they are able to utilize that pen and notebook at their own time, because it's their own property, right? But that reference book, it is the common property, it is maybe the property of system, and they have to utilize it with respect to, with mutual understanding with each other. So they are unable to utilize it at the same time. So in reminder section, local variables are utilized, and in critical section, common variables are utilized. So these are the four sections with respect to each and every process. कुठलीही प्रोसेस घेतला तर प्रत्येक प्रोसेस ह्या 4 सेक्शन मधून execution करते. So this is about the critical section. So we discussed in the interprocess synchronization the critical section problem. So what is the problem? जर critical section मध्ये आपण एकापेक्षा जास्त प्रोसेसेस ना एंटर करायला अलाउ केलं at a time, there may be the problem, and that problem is nothing but data inconsistency, right? Data inconsistency. एकाच वेळेस the common resource आपण एकापेक्षा जास्त प्रोसेसेसला ऍक्सेस करायला दिलं तर data may be inconsistent. So that to avoid that data inconsistency, so we solve that problem. So we discussed solutions of that problem, and these solutions we discussed as a part of syllabus. So under critical section problem, after discussion of the problem, we discuss solutions, and these solutions are nothing but Peterson's algorithm, synchronization, hardware, semaphore, and all these points. So all these points where we discuss the solutions. Under Peterson's algorithm, we discussed almost 3 algorithms. याच्यामध्ये 3 algorithm आपण डिस्कस केले. फर्दर हे अल्गोरिदम डिस्कस करायच्या अगोदर आपण काही बेसिक रिक्वायरमेंट काढल्या, म्हणजे कुठलं सोल्युशन त्याला आपण क्रिटिकल सेक्शन प्रॉब्लेम सोल्युशन म्हणू शकतो. तर जे सोल्युशन 3 कंडिशन सॅटिस्फाय करतं. सो दिस 3 कंडिशन्स आर, फर्स्ट वन म्युच्युअल एक्सक्लुजन, सेकंड वन progress, and third one bounded waiting, right? Again, this is the frequently asked question. Which are the conditions necessarily followed by each critical section problem solution? जे काही क्रिटिकल सेक्शनच्या प्रॉब्लेम साठी आपण जो काही सोल्युशन बनवणार आहोत किंवा जे काही सोल्युशन आपण तयार करणार आहोत, ते सोल्युशन कुठल्या 3 कंडिशन सॅटिस्फाय करायला पाहिजे? तर पहिली म्युच्युअल एक्सक्लुजन. व्हॉट इज बाय म्युच्युअल एक्सक्लुजन? at a time only one process should be there inside the critical section, other should be either in the entry section or in the reminder section or in the exit section. This is about mutual exclusion. Progress. So progress, when nobody is there in the critical section मध्ये जर कोणीच नसेल तर कुठल्या प्रोसेसेसला मोस्टली क्रिटिकल सेक्शन मध्ये एंट्री करायला अलाउ केलं जातं? तर ज्या प्रोसेसेस एंट्री आणि एक्झिट सेक्शन मध्ये आहेत, ज्या प्रोसेसेस एंट्री आणि एक्झिट सेक्शन मध्ये आहेत, अशाच प्रोसेसेसना आपण क्रिटिकल सेक्शन मध्ये अलाउ करण्यास परवानगी देतो. अदरवाइज वी आर नॉट अलाउविंग द प्रोसेसेस विच आर इन द रिमाइंडर सेक्शन. रिमाइंडर सेक्शन मधल्या प्रोसेसेसला आपण क्रिटिकल सेक्शन मध्ये जाऊ का देत नाही? तर त्या ऑलरेडी क्रिटिकल सेक्शन यूज करून बाहेर आलेल्या आहेत आणि आता सध्या रिमाइंडर सेक्शन एक्झिक्यूट करतात. इट मीन्स they have already used the critical section, that's why they are not allowed to enter in the critical section. So which processes are allowed? The processes which are in the entry section and exit section. So only such processes are able to enter in the critical section. So this is about progress. And third one, bounded waiting. So if any process is waiting for the critical section, so that waiting time should be bounded one. What is by bounded one? If It should be finite one, it should not be infinite one. For example, मी जर एखाद्या रिसोर्स साठी वेट करत असेल तर मॅक्सिमम माझा वेटिंग टाइम बाउंडेड असायला पाहिजे. मे बी मॅक्सिमम आय एम एबल टू वेट मे बी फॉर हाफ एन अवर और 1 hour or maximum 2 hours. So that 2, 1, half, so it indicates bound. That is particular limitation is there. So I should not wait for that particular resource for unlimited amount of time. म्हणजे 1 दिवस 2 दिवस 3 दिवस असं मी वेटिंग नाही करायला पाहिजे. So that is called as a unbounded waiting. So the waiting time should be bounded one, it should not be unbounded one. So this is about three requirements of the solution which is satisfying the critical section problem. So these solutions we discussed. Under Peterson's algorithm we discussed 3 algorithms. Under synchronization hardware we discussed 2 algorithms. Under synchronization hardware we discussed 2 instructions. One is test and set and another is the swap instruction. Then we discussed the concept of semaphore. Again, it is the synchronization tool which follows all these 3 conditions, which allows the processes to synchronize with each other. Then we discussed about monitor. It is another construct. It is a high level construct with the help of which we are able to provide the synchronization. So these tools are treated as a synchronization tools. Normally semaphore म्हणजे काय असं जर विचारलं तर you can immediately say that it is the synchronization tool used for synchronization, for interprocess synchronization. In the same fashion, monitor, it is another high level construct which is used for interprocess synchronization. Okay, so mostly the monitor is treated as a best tool for synchronization as compared to semaphore as well as compared to other algorithms. And when we discuss these algorithms, we said that this Peterson's algorithm, this is the first invention. So these algorithms, they were having some drawbacks, and that's why we proceeded to the next invention, that is synchronization hardware. Again, synchronization hardware is having its own limitation, that's why we proceeded to the semaphore. Again, semaphore is having its own limitation, that's why we proceeded to the monitors. And all these solutions we applied in the classical problems of synchronization. So sample 3 problems we discussed. One is bounded buffer problem, second is the reader writer problem, and third is the dining philosopher problem, right? So these 3 common problems in our real life we considered, and if you take any other problem from our real life, so it is belonging to either one, that is either reader writer problem or either bounded waiting problem, bounded buffer problem, or either it is a dining philosopher problem. So like that we discussed 3 problems, 3 classical problems of synchronization. So this much we discussed as a part of interprocess synchronization. Then in the second section, so I was talking about the second section where you people you listened to the 5th chapter very rigorously, but there onwards your response was very less, and that's why we just taken these 2 chapters almost within 2 to 3 hours. Okay, so deadlock we discussed a lot. On the deadlock we discussed about system model. So under system model we discussed the basic requirements of the deadlock. So what is by deadlock, what is by resource, what is by hardware resource, what is by software resource. These many concepts we that is how the resource is used. That is if I want to use any resource in the language of operating system, so we need to request that resource. एखादा रिसोर्स जर मला वापरायचा असेल तर पहिल्यांदा मला त्या रिसोर्सला रिक्वेस्ट करायला लागते, and once the request will be granted by the operating system, I'm able to use that resource, and after using I need to release it. So 3 steps are there: request, use, and release. Request, use, and release. So these are the 3 basic operations which are required in case of resource utilization that we discussed as a part of system model. Then we discussed about the deadlock characterization. So that is what are the characteristics of deadlock. We discussed necessary conditions for deadlock. So total 4 necessary conditions we discussed. Can anybody tell me? 4 necessary conditions to occur deadlock. Again, this is the frequently asked question for interviews. Deadlock जर व्हावा असं वाटत असेल सिस्टीम मध्ये, तर सिस्टीम मध्ये कुठल्या 4 गोष्टी required आहेत due to which the deadlock is going to occur. Beyond that, what is deadlock? It is the situation where waiting processes, they are waiting for another waiting process. अशी सिच्युएशन आहे सिस्टीम मधली की एक प्रोसेस जी वेटिंग आहे ऑलरेडी, म्हणजे ती कोणासाठी तर वेट करते, कुठल्या तर रिसोर्स साठी वेट करते, and that process is again waiting for another waiting process. That process is waiting for another process who is also waiting for some other resources, right? So this is called as a deadlock situation. So in the deadlock situation, what are the characteristics of deadlock? What are the necessary conditions for deadlock? Can anybody tell me?
Mutual exclusion, hold and wait, non-preemption, and circular wait.
Good, very nice. I think Chinmay is answering. Is it right?
I'm Chinmay's roommate, Ravi Rajpuri.
Okay, Raviraj. Okay, good. So Raviraj, very nice. So you answered correctly. So 4 conditions are there. First one, mutual exclusion. Second one, hold and wait. Third one, no preemption. And last one, circular wait. So this is the frequently asked question. Keep in mind. So these are the necessary conditions for a deadlock. So again, in the first condition, that is mutual exclusion. So how deadlock occurs due to mutual exclusion? Can anybody explain? ह्या 4 कंडिशन्स आहेत, याच्यापैकी एखादी कंडिशन जरी ऑकर झाली सिस्टीम मध्ये तर डेडलॉक होतो असं म्हटलं जातं, किंवा सगळ्याच्या सगळ्या कंडिशन्स ऑकर झाल्या तर डेडलॉक होतं सिस्टीम मध्ये. सो कॅन एनीबडी एक्सप्लेन मी हाऊ डेडलॉक ऑकर्स ड्यू टू म्युच्युअल एक्सक्लुजन? Yes. Okay. So let it be. Just listen carefully. So as these are the frequently asked questions, so that's why I'm taking rigorous follow up these things. So first condition, that is mutual exclusion. What is mutual exclusion? Only one process should be there in the critical section. Others should not be there in their critical section. मी काय म्हटलं, जेव्हा एक प्रोसेस त्याच्या क्रिटिकल सेक्शन मध्ये असते त्यावेळेस दुसऱ्या प्रोसेसेस त्यांच्या क्रिटिकल सेक्शन मध्ये नसायला पाहिजे. त्या मे बी त्यांच्या एंट्री सेक्शन मध्ये असू शकतात, किंवा एक्झिट सेक्शन मध्ये असू शकतात, किंवा रिमाइंडर सेक्शन मध्ये असू शकतात. ओके. सो बट ड्यू टू दिस म्युच्युअल एक्सक्लुजन ऑल्सो डेडलॉक इज गोइंग टू ऑकर. तर ही म्युच्युअल एक्सक्लुजन कंडिशन आपण कधी अप्लाय करायला पाहिजे? सो म्युच्युअल एक्सक्लुजन इज अप्लाइड only in case of non-shareable resources. Only in case of non-shareable resources. एखादा रिसोर्स नंबर ऑफ प्रोसेसेस ऍट अ टाइम जर युटिलाइज करू शकत असतील तर देयर इज नो नीड ऑफ ऍप्लिकेशन ऑफ म्युच्युअल एक्सक्लुजन. फॉर एक्झाम्पल, अज्युम दॅट यू आर सिटिंग इन द क्लासरूम. असं अज्युम करा की तुम्ही ऑफलाईन लेक्चरला बसलेला आहात क्लासरूम मध्ये, आणि बोर्ड आहे तुमच्या समोर, अँड ऑन दॅट बोर्ड टीचर इज रायटिंग समथिंग. Okay, so assume that board is treated as a resource. Board is treated as a resource, and teacher told you people read the things which are written on the board. Listen carefully. तुम्ही क्लासरूम मध्ये बसलेला आहात, बोर्डवर टीचर लिहितायत, आणि जे काही लिहिलेलं आहे ते तुम्हाला रीड करायचंय. जर मी तुम्हाला असं म्हटलं ऍट अ टाइम एकाच स्टुडंटनं रीड करायचंय, बाकीच्यांनी रीड करायचं नाही, because that is the resource. So if I say apply mutual exclusion over here, so I may say that when first student is reading, so other remaining, so assume that n students are there, so n minus 1 students, they will be in the waiting state. They will be in the waiting state, right? So don't know what is the waiting time. It depends upon the first one. पहिला स्टुडंट रीड करायला किती वेळ लावतो त्याच्यावर बाकीच्यांचं वेटिंग टाइम ठरलेलं आहे. इज इट राईट? सो रिमेनिंग स्टुडंट n-1 मे बी इन द वेटिंग स्टेट. Like that, n-2 will be in the waiting state, n-3 will be in the waiting state, like that onwards. And just consider the case of the last few students, those who are waiting from long amount of time. So they may wait for finite amount of time, and after that they will think that unnecessarily I am waiting, so instead I should leave the class. येते लक्षात? जर तुम्हाला मी म्हटलं बोर्डवर जे लिहिलेलं आहे ते एका वेळेस फक्त एकाच मुलांनी रीड करायचे, बाकीच्यांनी रीड करायचं नाही का? सो आय एम अप्लाइंग द म्युच्युअल एक्सक्लुजन. So what happens? Unnecessarily I applied the mutual exclusion and n number of processes are unnecessarily going to the waiting state. Unnecessarily going to the waiting state. So if I would not apply mutual exclusion over there, so I may say that all the students, they are able to read the data at the time. Are you getting my point? Yes, students? Hello? Are you listening to me?
Yes, ma'am.
ओके. सो जर आपण काही सिच्युएशन मध्ये विनाकारण जर म्युच्युअल एक्सक्लुजन अप्लाय केलं तर त्यांनी काय होणार आहे? वेटिंग टाइम इन्क्रीज होत जाणार आहे प्रोसेसेसचा. सो हियर आय टेकन n. सो अज्युम दॅट n इज 100 स्टुडंट्स. जर 100 स्टुडंट घेतले तर एक स्टुडंट रीड करत असेल तर उरलेले 99 स्टुडंट ते वेटिंग मध्ये असतात. त्यानंतर दुसरा जर रीड करत असेल तर उरलेले 98 स्टुडंट वेटिंग मध्ये आहेत. सो लाईक दॅट how many students they are able to read within maybe 1 hour, maximum 60. What about remaining 40? So they may go without execution for termination. They may go without execution. म्हणजे ते execution, त्यांचं execution न होता ते terminate होतील because their waiting time is very very big, so they can't wait, right? So this is nothing but the deadlock. So what do you mean by infinite waiting time? It is nothing but the deadlock situation. इन्फानाइट वेटिंग टाइम म्हणजे काय? डेडलॉक सिच्युएशन. अननेसेसरीली आपण फक्त वेटिंग करतोय त्या रिसोर्स साठी, आपण काहीच करत नाहीये. सो वी आर नॉट वर्किंग, वी आर नॉट एक्झिक्युटिंग, वी आर जस्ट वेटिंग फॉर द रिसोर्स and it is nothing but the deadlock situation. And that due to that deadlock situation, number of processes may be going for termination without execution. आणि हे एक्झाम्पल तुम्हाला अंडरस्टँड करण्यासाठी मी तुम्हाला अजून एक रिअल लाईफ एक्झाम्पल पण सांगितलं. जसं की तुम्हाला काहीतरी काम आहे, तुमचं काहीतरी महत्वाचं काम आहे प्रिन्सिपल कडे आणि तुम्हाला वेटिंग रूम मध्ये बसवलेलं आहे. तुम्ही किती वेळ वेट करणार आहेत? मॅक्झिमम 1 तास 2 तास. जर अख्खा दिवस तुम्ही वेटिंग करत असाल वेटिंग रूम मध्ये आणि जर तुम्हाला प्रिन्सिपल भेटत नसतील, सो मे आय से इट्स डेडलॉक. डेडलॉक म्हणजे तुम्ही स्वतःचं काहीच काम करत नाहीये आणि यू आर जस्ट वेटिंग फॉर द रिसोर्स and resource is not get allocated to you people. So what you will do? So maximum we will wait for 2, 3, 4 hours and beyond that what you will think, let it be. आता काय आपल्याला प्रिन्सिपल भेटत नाही, त्यापेक्षा बेटर आपण उद्या येऊया. सो व्हॉट हॅपन्ड ओव्हर हियर? सो युअर टाइम इज गेट वेस्टेड unnecessary, right? It is part of the deadlock situation. Are you getting my point? So this is nothing but the concept of first condition, necessary condition for deadlock, that is mutual exclusion. Then we discussed about hold and wait. म्हणजे मी काही रिसोर्सेस होल्ड करायचे आणि दुसऱ्या प्रोसेसने काही होल्ड करायचे. So that is P1 is holding R1, P2 is holding R2, and P1 is waiting for R2 and P2 is waiting for R1. So like that they are waiting for each other. त्यांनी काय केलेले? दोन रिसोर्सेस सिस्टीम मध्ये, दोन प्रोसेसेस आहेत आणि त्या प्रोसेसेसला त्यांची ऑपरेशन कंप्लीट करण्यासाठी त्यांना दोन्ही रिसोर्सेस लागणार आहेत. पण एकाने काय केलेलं आहे? एक होल्ड केलेलं आहे, एकाला धरून ठेवलंय, दुसऱ्याला धरून ठेवलंय आणि ते एकमेकांसाठी वेट करतायत. And to understand this concept, we discuss the real life example of two trains trying to cross the common platform. दोन ट्रेन आहेत, दोन वेगवेगळ्या रूटने येत आहेत, पण एका ठिकाणी त्यांचा कॉमन प्लॅटफॉर्म आहे, त्याच्यावरून त्यांना पास व्हायचंय. तर एका वेळेस जर आपण दोन्ही ट्रेनला अलाउ केलं तर ऍक्सिडेंट होऊ शकतो. So that's why we are not allowing to pass at a time. So we are passing only one train to that from that common platform, and then only second one is able to cross. Is it right? So that is this is nothing but the deadlock situation. So that is about hold and wait. काही resources hold करायचे आणि काहींसाठी wait करायचं. So that waiting time, we don't know whether that waiting time will be finite or infinite. So third one, no preemption. That is one resource can't preempt another resource, but they are able to preempt it through processes. One process is able to preempt another process by default. Through that process, the resource will be get preempted. For example, माझ्याकडे पेन आहे आणि तुमच्याकडे नोटबुक आहे. माझ्याकडे पेन आहे, तुमच्याकडे नोटबुक आहे आणि आपल्याला दोघांना पण रायटिंगची टास्क कंप्लीट करायची. सिच्युएशन अशी आहे की माझ्याकडे फक्त पेन आहे आणि तुमच्याकडे फक्त नोटबुक आहे. तुम्हाला जर राईट करायचं असेल तर पेनची गरज आहे आणि मला जर राईट करायचं असेल तर मला नोटबुकची गरज आहे. सो दीज आर द टू रिसोर्सेस, राईट? सो इफ आय वॉन्ट टू कम्प्लीट माय टास्क फर्स्ट, assume that we both are अंडर द कंट्रोल ऑफ वन ऑफ द थर्ड पर्सन. आपल्या दोघांवर कुणीतरी मॉनिटरिंग करते. जर तो थर्ड पर्सन म्हटला की यू हॅव टू कम्प्लीट फर्स्ट, इट मीन्स मी. सो व्हॉट आय विल डू, I will ask to you, so please release the pen, please release the notebook. मी तुम्हाला रिक्वेस्ट करेन, प्लीज नोटबुक द्या मला. आय वॉन्ट टू कम्प्लीट बिकॉज I am treated as a higher priority process by the third person. And once my writing will be over, again I will release both the resources and you are able to complete your operation. Right? So this is called as a no preemption. So only processes they are able to preempt the resources. So resources they can't preempt one another. एक रिसोर्स दुसऱ्या रिसोर्सला प्रियम्प्ट करू शकत नाही, पण एक प्रोसेस दुसऱ्या प्रोसेसला प्रियम्प्ट करून रिसोर्सेस रिलीज करू शकते. So this is about no preemption. And last one is the circular wait. That is P1 is waiting for the resource which is allocated to P2. P2 is waiting for the resource which is allocated to P3. P3 is waiting for the resource which is allocated to P4. And P4 is waiting for the resource which is allocated to P1. So this is called a circular wait. P1, P2, P3, P4. P1 is waiting for P2, P2 is waiting for P3, P3 is waiting for P4, P4 is in turn waiting for P1. So this is called a circular wait. So if we change this order, so we are able to break this waiting. जर ही काही रिक्वेस्टची ऑर्डर आहे ती जर आपण चेंज केली, so then only we are able to break that deadlock. Otherwise there will be the deadlock. So these are the 4 necessary conditions for deadlock. So that we discussed under deadlock characterization. One more point we discussed under deadlock characterization, that is the resource allocation graph. So can anybody tell me what is resource allocation graph? Again, frequently asked question, what then by resource allocation graph? Why it is used? Yes? Anybody? Yes, students? What is by resource allocation graph? Okay, so this is called as a resource allocation graph. So can anybody now tell me what is by resource allocation graph? या डायग्राम कडे बघून सांगू शकता का कोणी रिसोर्स अलोकेशन ग्राफ म्हणजे काय? Come on, you should be able to define it. RAG, resource allocation graph. Come on, students, I'm just taking the revision of operating system. Anybody? At least one student from the whole class. What is by resource allocation graph? Raviraj? Yes, Raviraj? Chinmay? Anybody from the class? I'm asking the question, what is the resource allocation graph? And I displayed the example of resource allocation graph in front of you. Come on. कोणी डिफाइन करू शकतंय का? वेदांगी? Yes, students, are you listening to me or not?
Yes, ma'am.
At least say yes, no. At least say we are live. We are listening to you. Let it be. You may not be able to answer. Vedangi is there?
Yes, ma'am.
Can you define it?
Ma'am, it is a graphical representation of allocation of the resources.
Good. The same thing I was expecting from last 2 minutes. So it is the graphical representation of deadlock situation. It is the graphical representation of deadlock situation. माझी सिस्टीम आहे, माझा कम्प्युटर आहे, मी बरेचसे ऍप्लिकेशन स्टार्ट केलेले आहेत, त्याच्यातले काही नॉट रिस्पॉन्डिंग आहेत, काही वर्किंग मध्ये आहेत. हे जर मला दाखवायचं असेल तर what I will do, I will take the help of resource allocation graph, right? So this is the pictorial representation of deadlock situation. It is the graphical representation of deadlock situation which is occurred in the system. Okay, so further it is also defined as, so this is the graph. So it is said as a graph. So it consists of two types of vertices. One is the set of processes and another is the set of resources. याच्यात दोन टाइपचे vertices आहेत. You are good familiar with the concept of graph as a part of data structure. Graph म्हणजे काय? Graph consists of number of vertices and these vertices are get connected with the help of edges. So what is graph? It consists of edges and vertices. In the same fashion, here two types of vertices are there. One is set of processes, another is the set of resources. So processes are represented with the help of circle and resources are represented with the help of either square or rectangle. So when to use square? When to use square and when to use rectangle with respect to resources? Come on. Yes, Vishaka?
Yes, ma'am.
कधी रेक्टँगल कधी वापरायचा आणि स्क्वेअर कधी वापरायचा? Okay, so when only one instance of that resource will be there, so we have to use the square. And when there are more than one instances of the resource type, so we need to use the rectangle. म्हणजे फॉर एक्झाम्पल मी जर प्रिंटर हा रिसोर्स घेतला, फॉर एक्झाम्पल इथं या एक्झाम्पल मध्ये सपोज R1 इज नथिंग बट प्रिंटर. आता प्रिंटर मध्ये पण वेगवेगळ्या प्रकारचे प्रिंटर असतात, लाईक इंकजेट प्रिंटर, लाईक लेझर प्रिंटर, एक्सेट्रा एक्सेट्रा, राईट? इंकजेट, माझ्याकडे जर सपोज 12 इंकजेट प्रिंटर्स असतील किंवा 12 लेझर प्रिंटर्स असतील, सो द रिसोर्स टाइप विल बी प्रिंटर अँड इट्स इन्स्टन्सेस विल बी 12. आर यू गेटिंग माय पॉइंट? त्याचे किती युनिट आहेत माझ्याकडे? 12 युनिट आहेत. किंवा तुम्ही मोबाईल घ्या, असं अजून करा की एक रेडमीचा मोबाईल आहे, तर माझ्याकडे रेडमीचे जर सपोज 10 मोबाईल असतील, सो आय विल से दॅट रेडमी इट इज resource type and how many instances are there? 10 instances are there, right? So this depends upon the number of instances. If number of instances of the resource type is only one, so you have to use the square to represent the resource. And if there are more than one instances of that resource type, so you have to use the rectangle. And further, so these are the two types of vertices. The graph consists of set of edges, set of processes and set of resources. आपण set म्हटले त्याला, set, set, because more than one processes are there and more than one resources are there, right? And further, two types of edges are there. One is called as a request edge, another is called as a assignment edge. Okay, one is called as a request edge. So over here in this diagram I have shown P1 to R1. So P1 to R1 and I have shown the arrow direction towards R1. So it indicates that P1 is requesting to R1. P1 is requesting to R1. Yes, who is not listening to me? Shubham Shende. Shubham Shende, you are just logged in. You are not listening to me. Shubham Shende, A75. Shubham Shende, lecture is going on. You are not listening to me. Roll number A75. Okay, so this is the case in case of online lecture. Let it be, I request all of you listen carefully. These are the basic concepts and these are required for your campus drives, and that's why I'm taking the rigorous revision I am taking. So I request all of you, please listen carefully. So here I was talking about the set of ages. So two types of ages are there. One is request age and another is assignment age. So what again set of ages, it is set SET because more than one request ages are there and more than one assignment ages are there. So here P1 to R1 it is called as a request age and R1 to P2 it is called as a assignment age because R1 is assigned to P2 and R1 is requested by P1. So if it is requested, the arrow direction will be from process to resource, and if it is allocated, the arrow direction will be from resource to process, right? So this is about the resource allocation graph, and it is the pictorial representation of the deadlock situation. And after that, actually these 2 points we discussed as a part of deadlock characterization. Then we discussed about methods for handling deadlocks. And under that methods, we discussed total 4 methods called as deadlock prevention, deadlock avoidance, deadlock detection, and deadlock recovery, right? So 4 methods we discussed, methods for handling deadlock prevention. So in deadlock prevention, we just try to prevent the deadlock with the help of 4 protocols with respect to these 4 necessary conditions. ज्या काही 4 कंडिशन्स बघितलेल्या आहेत आपण नेसेसरी कंडिशन्स, त्या कंडिशन्स कशा होणार नाहीत याच्यासाठी आपण एक एक प्रोटोकॉल डिझाइन केलेले आहेत. So mutual exclusion. So it is the protocol. Apply mutual exclusion only on non-shareable resource. Don't apply it on shareable resource. जर आपण नॉन शेअरेबल रिसोर्स वर जर म्युच्युअल एक्सक्लुजन अप्लाय केलं तर डेडलॉक होणार नाही, आणि जर आपण शेअरेबल रिसोर्स वर अप्लाय केलं सो देयर विल द डेडलॉक. सो दिस इज द प्रोटोकॉल, right? So we have to design the protocols in case of deadlock prevention to avoid these conditions. Under deadlock avoidance, we discussed about the algorithm, and the major algorithm we discussed about Banker's algorithm. आपण अल्गोरिदम डिस्कस केला, बँकर्सचा अल्गोरिदम डिस्कस केलाय अवॉइडन्स साठी. अगेन फ्रिक्वेंटली आस्क्ड क्वेश्चन, Banker's algorithm is used for deadlock avoidance or prevention. So you should not confuse. So it is used for avoidance. So safety algorithm is used for avoidance or prevention. Safety algorithm is used for avoidance. So safety algorithm is the part of Banker's algorithm. So under Banker's algorithm, we discussed 2 algorithms. One is the resource request algorithm and another is the safety algorithm, right? This is about deadlock preemption and this is about deadlock avoidance. So under deadlock avoidance, we discussed about the safe state, unsafe state. Again, we taken the example, best examples. जे काही दिलेले resources आहेत, जे काही processes आहेत, या सगळ्यांना available असलेले resources utilize करून processचा sequence decide करून how we are able to utilize all these resources within the available processes. So for that purpose, we decided the sequence. कुठल्या sequence मध्ये आपण processes execute केल्या तर resources पण utilize होतात आणि सगळ्या processes पण run होतात. So that sequence we are calling it as a safe sequence, right? So we discussed about resource request graph algorithm. Under that, we discussed about claim age. So with the help of claim age also, we shown that claim age in the sense, so in future it will be claimed or it will be requested, and the claim age is shown with the help of dotted lines, right? जर या डायग्राम मध्ये या रिसोर्स अलोकेशन ग्राफ मध्ये 2 डॉटेड लाईन्स आहेत, एक P1 to R2 आणि P2 to R2 कडे. जर तुम्ही ह्या याच्यामध्ये जर सपोज P1 P2 to R2, so if you are converting, if you are allowing P1 to use R2, जर P1 नी पहिल्यांदा रिक्वेस्ट केली तर P1 to R2 जी काही डॉटेड लाईन आहे ती तुमची रिक्वेस्ट एज मध्ये कन्वर्ट होईल. And after request, the resource may be get allocated to P1, right? It will be get allocated to P1. म्हणजे request age परत assignment age मध्ये convert होईल आणि दोन्ही resources P1 ला allocate होतील. So P1 will go for execution, and after execution, it will releases all the resources, and then P2 will going to for okay. So we discussed this concept, resource allocation graph algorithm and safety algorithm. Under safety algorithm, we discussed the concept of that safe state and unsafe state. So this is about Banker's algorithm. Under Banker's algorithm, we discussed about safety algorithm and resource request algorithm. So 2 algorithms we discussed. So this is safety algorithm and resource request algorithm. So this comes under deadlock avoidance. And then we discussed about deadlock detection. So under deadlock detection also we discussed 2 algorithms. One algorithm is used for single instance of each resource type. जेव्हा resource type चे एक instance असतात त्यावेळेस आपण wait for graph चा use केलेला आहे. And another algorithm that is several instances of resource type. Resource type चे एकापेक्षा जास्त instances असतील तर detect कसं करायचं. So for that purpose we use the algorithm. And at last we discussed about the recovery from deadlock. So how to recover the deadlock. Normally जेव्हा आपण मशीन स्टार्ट करतो आणि बऱ्याचशा विंडोज ओपन करतो त्यातल्या काही विंडोज वर्क होतात काही विंडोज नॉट रिस्पॉन्डिंग असतात. So mostly the not responding windows we are terminating, right? आपण डायरेक्टली क्लोज करून परत एकदा ती एखादी फाईल ओपन करायचा प्रयत्न करतो. I hope you are understanding my concept. Are you agree with me? Yes, students, are you listening to me?
Yes, ma'am.
जेव्हा एखादी विंडो नॉट रिस्पॉन्डिंग येते त्यावेळेस तुम्ही काय करता ती विंडो क्लोज करता म्हणजे काय ती प्रोसेस तुम्ही टर्मिनेट करता. सो नॉर्मली वी आर युजिंग द प्रोसेस टर्मिनेशन मेथड टू रिकव्हर द डेडलॉक मधून बाहेर जर यायचं असेल तर मोस्टली आपण प्रोसेस टर्मिनेशन करतो. बऱ्याच वेळेला सगळेच जर विंडो हँग झाले असतील तर पूर्ण मशीन आपण रिस्टार्ट करतो म्हणजे सगळ्याच प्रोसेसेस आपण फोर्सफुली टर्मिनेट करतो. सो दॅट इज कॉल्ड एज अ फोर्सफुल टर्मिनेशन, abort. So under process termination, either we are using abort all deadlock processes or abort one process at a time until the deadlock cycle is eliminated. जे एखादी प्रोसेस टर्मिनेट करायची आणि परत चेक करायचं की तिथं काही सायकल ऑकर झाली आहे का. सो इफ देर इज नो सायकल so there will not be the deadlock. Alright, this is about process termination. And second method, that is resource preemption. So जर डेडलॉक ऑकर होत असेल तर एखादा रिसोर्स प्रिएम्प्ट करायचा प्रयत्न करा. कुठला रिसोर्स प्रिएम्प्ट करायचा सो दॅट विल बी सिलेक्टेड. सो सिलेक्ट अ विक्टिम, then roll back and starvation. So try to avoid the starvation. So these 2 methods we use for recovery from deadlock. And these are the 4 points which we discussed as a part of 5th chapter. And the last point was combined approach to the deadlock. That is, sometimes in our system we need to apply deadlock prevention also. So maybe though we applied prevention, so again we maybe go to the avoidance concept. Prevention apply केलंय आपण पण सगळंच काही प्रिव्हेंट झालेलं नाही त्यामुळे आपल्याला परत डेडलॉक ऑकर झालेला आहे किंवा होणार आहे. मग आपण अवॉइड करायचा प्रयत्न करणार आहोत. मग अवॉइड जरी करायचा प्रयत्न केला तरी पण डेडलॉक होणार आहे तर त्या केसमध्ये डेडलॉक होऊ देणार आहोत. Then we are detecting it and then we are recovering it. Okay. So like that, this is about the deadlock chapter. So up till now we revised total 5 chapters of OS. So today we'll stop here and maybe in the next lecture we'll revise the major topic from OS, that is memory management. So under memory management we'll revise memory management and virtual memory, and then we'll take the overview of IO system and then we'll proceed to the Unix operating system. Okay. So any doubt about this? Anybody is having any doubt? Yes. So today we'll stop here. Just drop your attendance in the chat box mentioning your division and roll number, all of you, and you can leave.